Hey everyone, welcome to this section. In this section, we'll discuss regarding the concept of Zero Trust Network Access or ZTNA at a very high level overview. And we'll discuss, what does ZTNA stands for, what is the concept of Zero Trust is all about, and why it is gaining so much, popularity, and what it is trying to overcome with concept of, legacy networking architecture. So let's go ahead and get started. So we'll talk about the concept of zero trust network access, also called as ZTNA. It is sometimes also referred to as zero trust network security as well. So the idea is, it is a cybersecurity framework, right? So it is not a technology, it is not a protocol, it is not a product. Okay, so it's more of a cybersecurity framework that ensures users and devices are granted access to some specific resources only after the rigorous authentication and authorization takes place. So unlike when you have any traditional security models which assume that users which are inside the network, they are trustworthy, but your ZTNA operates on the principle of never trust and always verify. Never trust and always verify. So this is the major principle that ZTNA is based upon, right? So the whole idea of ZTNA being, it's more of a cybersecurity framework rather than calling it as a technology or calling it as a protocol or a standards. It's more of a framework, right? Where, as I've told you, the users and the devices that the users are using, and the applications or the resources that the users are willing to access are given or are granted permission, are granted permission after that rigorous verifications or rigorous concept of authentication and authorization. So once the user are passing this authorization and authentication test, then only the users with the devices that the users are trying to access the respective resources are granted with the respective permission, right? So don't forget to tell this word whenever you are asked regarding zero trust network access. So you should say that it's a framework which follows the principle of never trust and always verify. Now the first point first is, why is ZTNA important, right? So why it is gaining popularity and why is ZTNA important in today's networking environment, right? So in networking environment that we have today, think about any traditional security models that rely on firewalls and VPNs to protect your networking gears. So you might have a firewall, right, that is connected to a router, and from that particular router you connect a switch, and that switch will go and connect to your endpoints, right? So I just draw the endpoints like that. So bear me with my diagram here, but yeah, hope you understand, right? So I'm drawing the endpoints that is plugged to my switch. So this is kind of a traditional network design what you can think of, right? So I will have a firewall, I will have a router or a router as you say, I'll have a network switch, and then I'll have this endpoints. Now the whole idea is, this is basically called as the inside network, or it can be called as a trusted network, right? Which is any interface that is connecting to the router and this. So the interface pointing downwards towards the router and towards the switch, those are all your trusted interface. And anything which is pointed, that is, I've got interface from the firewall that is connected to the ISP router, right? The ISP router, and from there we can reach to the world of internet. Anything in that access, anything towards this outside or the external world are considered as untrusted, right? Are considered as untrusted. So it's more of the perimeter security nature, right? So more of your traditional security was or the traditional security models was relying more on firewalls and the VPN solutions to protect your corporate networks, or basically these corporate endpoints. However, these models have some weakness. So first of all, the weakness that points to me, the first thing that comes in my mind is overly permissive access. So this is one of the important thing, overly permissive access, which means that once inside a network, users often have broad access, right? So users, if they are trying to access a particular application, but if you grant that user an access to a particular network address, that means the user will have a broader access, and it can do something called as lateral movement and access other applications or other resources which the user might not be requiring, right? So that is the reason you'll have increased cyber threats, which means that cyber attacks, think of ransomware, phishing, any type of insider threats, so those cyber attacks can exploit the weak authentication mechanism, right? And of course, remote work and cloud adoption. So this is because the employees, the third parties and contractors, they work remotely, requiring secure access which is beyond your traditional firewalls. So ZTNA addresses these challenges by ensuring that the strict access controls are granted or are always in process, and it will reduce the attack surface, right? So ZTNA's job is to address all those challenges that is mentioned here. So to grant only least privilege based access, rather doing any overlay permissive access, reduce the attack surfaces, reduce the public IP scope to be found, or reduce any IP address spoofing, right? That means reducing the IP based attack surfaces, and verifying the remote users and the remote workforce, and also the devices that the remote works for are trying to use to access your corp application by going with device posture. So yeah, which can ensure that the right cybersecurity approach is taking place, and ZTNA can handle this, right? So let's talk about the core principles of your zero trust networking. So let's discuss regarding the core principles now. So what are the core principles of ZTNA, right? So first is first, verify before granting access. This is very, very important thing. Verify before granting access. So I'm a user, right? So think I'm a user and I'm willing to access some corp resources. So I'm sitting at my home and I want to access my corporate resources that is hosted inside my company's data center, right? So first of all, there has to be the solution which should authenticate me. That means whenever I'm trying to access that particular corp resource from my PC, so my corporate should implement the zero trust networking solution, right? Or the entire framework, which should have a solution that could identify my identity, right? So it should find out the identity and access management policies should be configured. So that means with your this verify before granting access, this IAM policies has to be configured. So IAM should enforce multi-factor authentication as well. That means the organization must have IAM policies and to verify my credentials, and also for better security it should also enforce multi-factor authentication. Next, access will be granted based on who the user is. All right, what device they are using. I mean, think of device posture check will be done, and the context of the request that has been made, right? Context of the request that has been made, and let us say it will also check for the user's location, from which location the user is trying to access the data, the time of that access, and also the user behavior pattern, right? So those are called as context, and as well as what type of data that the user is trying to access. I should say data type, or you can say application type, right? So the next principle of your ZTNA is least privilege access, which is very, very important. Least privilege access, which is also called as LPA. That means users and devices only receive the access to the minimum resources that is required to perform their task. So unlike VPNs, which will provide broad access, ZTNA restricts access to specific application only. All right, that means me as a user, I will not be able to access the whole network. So I will be able to access only the application that I'm granted with the right permission. All right, next is your micro segmentation, which is another core principle. Micro segmentation. That means the network is divided into smaller sections, and even if one segment is breached, the attacker cannot move freely between those multiple micro segments, okay, which is important. So the ZTNA networks are always micro segmented. That means the servers that is hosting the applications are always segmented, okay. Next we have continuous monitoring and adaptive trust, which means that the access is continuously re-evaluated. So whenever the user has been given an access to talk to an application, so the access will be always re-evaluated based on the real-time behavior and risk. And if a user exhibits any sort of suspicious behavior, their access may be revoked automatically, okay. And last but not the least principle is application and data centric security. So ZTNA, the idea of ZTNA is to protect your individual applications instead of exposing the entire network, and users cannot see the applications that they don't have access to, which will definitely reduce the attack opportunities in terms of cyber threat is considered, right? So first of all, think in that way how this ZTNA process would work, right? So let's say that we have got a small diagram that I can draw here. Let's say I have got a user who is sitting remotely, and there is, let us say, that zero trust cloud, and behind that zero trust cloud the user is connecting to the zero trust cloud using the help of internet, and behind the zero trust cloud it is also connecting the data center, the core data center, and inside this core data center you have got the servers, right, that is hosting the applications, okay. So think like this is your zero trust cloud, okay, and it will have the respective policies that you want to configure for zero trust, right? For separate policies for internet access, separate policy for SaaS application access, separate policy for private application access. So if the user is trying to send traffic to internet, so this user is trying to send traffic to internet, the traffic will be intercepted by this zero trust cloud. Then the traffic will be matched against the the zero trust policies for internet access, and then if the policies is allowing the traffic to flow, the traffic will be leading towards the internet resources, or let us say towards your SaaS application resources, right, or towards your SaaS application resources. Similarly, if the user is trying to access any private application, let us say a Salesforce application or Dropbox application, which is sitting at the data center, might be at some public cloud. So in that case, the traffic will be again intercepted by the zero trust cloud over here. The traffic will be found a match against that private application access policies, and then if those private applications are allowing the traffic to flow, then the traffic will be allowed to talk to the respective applications. Now for the private applications, you need some sort of a separate architecture where we have the concept of zero trust connector, and we can talk about these things later when we really deep dive into zero trust networking and its core architecture, core components, etc., in separate class of zero trust networking altogether. But at the very overview level, what you should know is so users can send traffic which is either based on internet, or the traffic which is either based on SaaS. Let us say this is my internet traffic, or it is a traffic which is towards public SaaS applications, or users can request traffic to access any private application that is hosted inside any on-premise data center, or could be inside any public cloud environment. For all those type of traffic, the traffic is intercepted by the zero trust cloud, where all the respective policies for internet access, SaaS access, the private application access are configured and are and all the traffic will be logged here. So all the user traffic will be logged over here, and then based on the policies, if the policies are allowing the traffic will be allowed to go to the respective destination. Okay, so you are moving away from that traditional perimeter security to more of making that user to access any internet or SaaS service or any private application service from anywhere, so that users could be remote and the user could be part of any network, right? The user could be sitting in any network, the user could be sitting in any location, right? So it is more of a road warrior or more of a roaming kind of a user, right? So you are not granting the user to access the entire network, you are not granting the user to access multiple applications. So you are going with the least privilege policies. So whenever the user makes a request to access an internet or SaaS application or maybe private applications, first of all the traffic gets intercepted at the zero trust cloud. The traffic will be going with all those respective principles. So the user has to be authenticated following the IAM policies and the MFA. Once the user is authenticating itself, then the context about the user will be verified. Then the user will be granted with a least privilege access. Make sure the backend applications are always micro segmented. The user traffic will be continuous monitored, and the principle of ZTNA is more focused to application and data centric security, right? So hope it is clear. Now regarding the process, how it works, so I can say that how does ZTNA works. So the first thing first is user request. User will make a request for access. Now this access could be towards the internet resource, towards SaaS application, or towards private application. So a user or device attempts to connect to an application, right? Next step would be identity and device verification. Identity and device verification will take place at this level. That means multi-factor authentication can confirm the user identity. The device is checked for security compliance. Let us say OS updates are right or not, antiviruses are up to date or not, etc. Next will be your context-based policy enforcement, which means that access is granted only if all the security conditions like user role, your device status, network location, they are all met. Then only the access will be granted. Okay. Next will be your secure connection will be established. right? That means the user connects directly to the application via a secure tunnel without exposing the whole network. That means now the user to the backend application, it is will be through a secure tunnel, right? And this user to that particular application tunnel that we are creating does not give permission for the user to access any network scope. That means the user will never be knowing what is the IP address of the destination server. The user will never know what is the network address or IP address of the server that is hosting the applications, right? And last but not the least is continuous monitoring. Continuous monitoring, that is very, very important. So which means that user behavior is continuously monitored in real time, and if the risk increases, the access can be revoked. All right, so ZTNA versus VPN, you can think of some key differences. So ZTNA versus VPN, you can think of, let us say if I talk about a feature, versus so the feature for ZTNA and the feature for VPN. Okay, so the feature, if it is, let's say if it is access control, the feature is access control. So ZTNA will be doing, per application based access, whereas VPN services will give full network based access. Okay, that's important. Regarding the next feature, which is say security, so ZTNA does provide stronger security. It has got that least privilege access principle, whereas your VPN model, VPN model, it's having a weaker security as compared to ZTNA, and it offers broad access, which is really weakens the cyber threat scope, right? Regarding performance, you can think about performance. So regarding performance, with ZTNA you get faster performance, and it is cloud based because you are not relied on any particular product that you need to purchase, right? So it's all cloud based, and performance would be a bit slower as compared to ZTNA because of network routing. So due to dependencies on hardware, also due to network routing. All right, regarding scalability, so that any cloud solutions will be scalable in nature. So since ZTNA is a cloud solution, it is called as cloud native solution, so it scales easily, so based on the demand. But in case of VPN, it is harder to scale. Okay, and last but not the least, regarding user experience, for ZTNA, it will offer seamless user experience. It will work from any device, whereas in case of VPN, it requires a VPN client to be installed, although in case of ZTNA you need a ZTNA client also to be installed, but the experience is smoother as compared to, or you can say the experience is transparent as compared to VPN, which is kind of a manual in nature. So many organizations are replacing VPNs with ZTNA for better security, for better performance, and for better scalability, right? There are multiple deployment models that you can have with ZTNA. There are multiple vendors which offer ZTNA solutions. So Palo Alto is one of them. So Palo Alto Prisma Access, Palo Alto SASE solution, Palo Alto SD-WAN solutions are all part of your, all follows the ZTNA principles, right? There are other vendors as well. So yeah, so when you think about the ZTNA deployment models, so there are various models by which the ZTNA services could be deployed for the users to have an access. So first is service based ZTNA, which is a cloud hosted model. That means it is managed by a third-party security provider, and it is ideal for organization which uses cloud applications like Office 365, Google Workspace, etc. So you can have the traffic routed to that service-based ZTNA or cloud-hosted based models, right? Next is your self-hosted ZTNA. self-hosted ZTNA, which means it is deployed on premise. It is deployed on premise, so it is managed internally using private infrastructure, and it is suitable for highly regulated industries, for example finance or healthcare, so where more compliance standards are maintained. And last but not the least, you have got hybrid ZTNA, as the name says, so you can combine both cloud-based and on-prem solutions, and it is useful for organization with a mix of cloud and legacy systems, right? So let's talk about the benefit of ZTNA that we get. So hope as of now you understand that ZTNA can offer multiple benefits as compared to VPNs or legacy traditional perimeter based network. So first point that I can talk is improved security. So it will reduce the attack surfaces and prevents any lateral movement of threats. It will offer better user experience. That means it will provide seamless and fast access without requiring any sort of VPN based logins. It will have simplified IT management. That means it will reduce the complexity by eliminating VPNs and firewalls. It will reduce the insider threats, which is very, very important, because normally we think only about the external threats a lot, but it will reduce the impact of insider threats to ensure that employees and third parties get only the access that they need, only the required application access, or only the required level of access that they need. And enhanced remote work security, right, which means that it will protect the access for employees working from anywhere, right? So so as I've told you, so ZTNA is a very, very key component for the zero trust architecture. And the zero trust architecture, when you think about it, so ZTNA, so think about the zero trust cloud which I've drawn here. So inside the zero trust cloud you have got a zero trust architecture, right? In that architecture there will be several components, right? So just to write down the several components under the zero trust architecture, the first component is IAM, that is called as identity and access management. Second component is multi-factor authentication. Third will be endpoint security component or endpoint security solutions, data encryption solutions, right? Then and SIAM solution, which is more of security information and event management, also known as SIAM solutions, right? So ZTNA complements other security tools to create a very, very holistic zero trust security model, right? So the future of ZTNA is very bright. So as we have growth in cloud security, so more organizations are adapting SASE, that is Secure Access Service Edge, which includes ZTNA. AI powered security, so its AI driven threat detection will enhance the ZTNA capabilities and increase adoption in IoT and 5G, which we are seeing today. So securing connected devices using ZTNA will become very crucial. So ZTNA is rapidly becoming the gold standard for securing your remote access and modern cyber security. That is the reason it is very important for all of us to understand the overview and basic of it. All right, so I hope it is clear. You understand the basic of what is zero trust is all about, and looking forward for you to look into the other videos and other contents. So if there is any queries, let us know. We'll be happy to assist. Thank you so much. Enjoy the course. I'll see you in the next lecture.